Hi Alice. There's a lot of assumptions with this that you know what this is. It's a straight line graph. Um, you know a bit about it. So, yeah, so let's just run through bits that you should know by now if you're doing this exercise. Okay, we've got the y-axis, we've got the x-axis, um, and if you get a straight line, I don't know, any diagonal straight line or something like that, then you should have already learned that any diagonal straight line, not vertical, not horizontal, those are special cases, but a diagonal straight line, be it going uphill or downhill, can be written in the format of a single y equals so many lots of x's plus c. Now this c tells you, I'm just assuming you know this, I mean there's a whole lesson that I could do, describing what these two are. The C is basically the y-axis intercept, where it crosses, where the graph crosses the y-axis. So there's the y-axis, and I can guarantee that as long as you've got a single y here, not 3y, not 2y, but a single 1y, as long as you've got that, then this number here will be the number where it crosses the y-axis. If there isn't a number there, it means that the line crosses through 0. Okay, so that C is this number here. The M, well, that is the steepness of this line, the gradient. Now, because it's a straight line and it's not a curve, it means wherever you are on this straight line, the gradient or the steepness is the same all the way along it. So you can measure the gradient. Gradient is measured as, so gradient is also signified by the letter M, and that's to do with Latin. There's a word I can't remember off the top of my head at this moment, and I'm not going to make a mess of it. But that M stands for something in Latin. The word that describes begins with M. M is gradient. You'd think they'd use G in the modern day, but it's M. Okay, and it always has been. Gradient is a measure of this. Okay, it is simply your increase in y over the increase in your x direction, increase in x. Okay. When you're in a parent's car and you see these signs that say it's a red triangle and it says there's a little wedge, something like that, and it's a warning that might be something like underneath 25%. What that actually means is there's a hill going up or going down. It's basically approaching a gradient. And what 25% means as a fraction is 25 over 100, which you should know cancels down to 1 over 4. Now what this actually means is to increase in your y by 1 unit. Now unit can be anything you want: meters, miles, kilometers, fingers, length of arms, whatever it is. One increase in the vertical sense, you have to travel horizontally in the x direction, horizontally, 4 of those units. So I'll show you what I mean. If you go across, let's say that's the 1 unit, 2 unit, 3 unit, 4 unit. Going across 4 units means you'll have a rise in the height of positive 1 unit. So the line, the hill that you'll be going up or down, will be looking like that. That's a 1 in 4 or a 25% hill. That's what it means, these road signs. It is always the increase in the vertical, the y direction, over the increase in the x. Now remember that if it was minus a quarter, it means you're still going across 4, but you are dropping, you are falling by 1 unit down. So this time the gradient would be looking like that if it was negative a quarter. That's why negative gradients go downhill and positive gradients go uphill. Okay, so this is guaranteed to be a positive gradient. Now, how do we use this information? Well, we can quickly look at this. You can always drop a vertical stone. I also pick on a coordinates up here, drop a stone, and you can choose your triangle. It can be there. You measure this. Let's say, I don't know, that's reading off the scale. Let's pretend it is 4 units. reading off the scale horizontally, let's pretend that that's 4 units. The increase in y, which is 4, divided by the increase in x is 4. 4 over 4 cancels down to 1. That gradient will be 1. Now you can choose this triangle any way you want. You could have chosen a massive triangle like that. You'd still get whatever that is, 8, and that's 8, let's say. I'm just making these numbers up. The gradient would be the same here as it is here, so it doesn't matter where you take the gradient on a straight line, it's always going to be the same. You could even choose this triangle if you wanted to, just here. Okay, measure that length using the scale, and measure that length and divide that by that, the vertical by the horizontal. Okay, and that is the m. So the number m is your gradient, and it is always the number that is timesing the x. Okay, the number at the end, if there is a number, tells you where, as long as this is a single y, tells you where it crosses the y-axis. So coming on to this question then, assuming that you know that, okay, that was a very, very quick run through about straight line graphs. It says find the equation of a line, so you're trying to design the equation of the line, the rule for the line, that is perpendicular to this. Okay, well, first of all, you know that y equals mx plus c. If we just turn this around so the x's, including its sign, is in the front here, you might be able to see it a bit better. Y equals minus 2x, and that's a positive 1, so plus 1. So you can see this graph crosses the y-axis at 1, and it's got a gradient of minus 2. Okay, minus 2 isn't a fraction, but you can make it a fraction, minus 2 over 1. And what that means is that you are going across 1 unit and you are falling 2 units, 1, 2. So that is what, not very good, not well done, but that is what the gradient looks like. The line, this line, is a steep line going downhill because it's a negative gradient, and it crosses the y-axis at 1. So I don't know, there's the y-axis. It would look something like that. If that's 1, it looks something like that. Okay, not that you need to know that, but let me just tell you, because I'm assuming you know that, there's so much that you need to know, especially this bit here about perpendicular gradients. Well, if you want another gradient that is parallel to that, it means it's got equal steepness. It means that the gradient of this line must also be minus 2. If the gradient of this line is minus 2 and you want it parallel, you want it equally steep. So any line that has got a gradient of minus 2 will be parallel. You should have seen a law now to actually work out what your gradient needs to be for the graph you are designing if you want it to be perpendicular. Perpendicular means right angles to. So you want a graph, you're designing a graph that goes right angles to the graph that you've got is 90 degrees to. And the law is you get the gradient of this line, and you need to do 2 things. You need to reciprocalize it, and you need to then change its sign, S-I-G-N. Okay, so the gradient of this line here, look, is minus 2. So we'll treat that as a fraction. You can always make it as a fraction if it's a whole number by putting it over 1. Reciprocalize it. I'm hoping you know what reciprocal is. If you don't, it's dead easy. You just simply flip the fraction upside down. So that goes up there and that comes down there. And change the sign. So it was a negative, it's now a positive. If it was a positive, it'd become a negative. So change the sign and reciprocalize it. So the new gradient, we're designing this new graph, let's say, and we want this gradient to be perpendicular to this, right angles to. So the 2 things you've got to do is change the sign so it's now positive, it's not a negative, and flip it. So this is 2 over 1 is now 1 over 2. Okay, so that's as much as we know now. What you've just done is find the equation that passes through. Well, we haven't done this bit yet. All you've done so far is find a line that is perpendicular to this. That is a line that's perpendicular to this. Wherever you put, where it crosses the y-axis, Doesn't matter what you're designing. There's millions of possible lines you've just done here, but to get the specific one, you've got to work out what C is. You've got to work out where it crosses the y-axis. Okay, and how you do that is you use this last thing here. So you've now got a perpendicular gradient. You've done the first bit, but you've got to make sure that your line specifically goes through the coordinate 1, 3. You've got to design this exact line, so you need to know where it crosses there. How do you do it? Well, this is how you do it. We don't need that anymore. That's what we've got so far. We know the gradient is definitely that. So the y-ordinate is exactly equal to half of whatever the x is plus a number, and this side is equal to this side. So we're just going to use this coordinate. We're going to use 1, 3. What this means is that x is 1 when y is 3, and that agrees to this rule. So replace the y with 3, and a half x means simply a half multiplied by x, which is 1. So I don't like doing a times, but an x looks like a times. But there you go. A half times a half multiplied by x is 1. So half times 1, we don't know what c is, we're trying to find that, plus c. So let's have a look at this. A half times 1 is a half. So 3 equals a half plus c. And the next thing is to solve this equation. You've got to get rid of this. To work out what c is, you've got to get rid of this. So take a half from both sides. So take a half from here and take a half from here. You end up with 2.5. Now, mathematicians don't like stuff like 2.5, and we certainly don't like stuff like 2.5. What we much prefer, that means exactly the same as that, but we like to write it as a top-heavy fraction. So how do you make this as an improper top-heavy fraction, improper fraction? Well, 2 times 2 is 4. That represents 4 halves, plus the 1 half. That can also be written as 5 over 2. So that is the same as that, or that is the same as that. 5 over 2 is how we write it. Okay, so when you take a half from both sides, you end up with 5 over 2 is equal to c. So now you've spotted where it crosses the y-axis. So now you can come back here and rub that out and put in positive, because it is a positive, 5 over 2 plus 5 over 2. And there, you've designed the graph. You've made sure it is perpendicular to this graph, but it specifically goes through this point here, okay, plus 5 over 2. Okay, it's a very tough question. That is right at the end of straight line graphs. Now, I'm not too sure what Mr. Hegarty's done in showing that, but I think it's Mr. Mellor that will have set it. So I'm presuming you've done a lot of work before this in watching those videos. I hope this makes some kind of sense. If not, let me know. We'll have to, go back to the beginnings and find out what's, how much you do know. Okay, I hope that helps.